update is one of the most commonly used functions in Unity. It's called once per frame on every script that uses it. Almost anything that needs to be changed or adjusted regularly happens here. The movement of non-physics objects, simple timers, and the detection of input are just a few things that are usually done in update. Note that update is not called on a regular timeline. If one frame takes longer to process than the next, then the time between update calls will be different. Fixed update is a similar function to update, but it has a few important differences. Fixed update is called on a regular timeline and will have the same time between calls. Immediately after fixed update is called, any necessary physics calculations are made. As such, anything that affects a rigid body, meaning a physics object, should be executed in fixed update rather than update. When scripting physics in the fixed update loop, it's good practice to use forces for movement. Let's take a look at the difference between fixed update and update calls. In this example, we're logging to the console with each fixed update and update by adding the value of time.deltaTime. When I press play and pause, you can see that the time between fixed updates is always 0.02, whereas the time between updates varies. This can be shown even more clearly by collapsing the console. If I play now and pause, you can see that all of my fixed updates are collapsed into one. Even though there's a large number of them, we can see that they are all 0.02, whereas the update times vary. Update and many other special functions in Unity can be created quickly and easily in Visual Studio by using the MonoBehavior scripting wizard. In Visual Studio, position the cursor where you want the new function to be inserted, then press Ctrl-Shift-M to launch the wizard. In the Create Script Methods window to launch the wizard. Then press Ctrl-Shift-M to launch the wizard. To the name of each method you want to add. Choose the OK button to exit the wizard. In this way can help you to avoid errors in your code and also help you to discover what functions are available as you're learning.
Hey, what's up? I'm Jason, and what I got to do and how I use update and fixed update now to make everything nice and smooth and just work cleanly. So here I've got a little example with a ball that bounces around. I can see I can jump and control it. That's what we'll be using as our example. But before we dive into the code for all this stuff, we're going to need to cover what update is and what fixed update is and what the differences are real quick. So the best explanation I found, or at least the simplest and most to the point one, was on this Stack Overflow post, which is also referencing a forum post. And it just says that update is run once per frame, which we all know because if you add a new Unity script, you see the update is called once per frame. But when you add a fixed update, you don't get a notification like that or any message, right? So you don't get this next little bit of information thrown in your face all the time, which is that fixed update can run 0, 1, or several times per frame, depending on how many physics frames there are per second in the settings and how fast or slow your game is running. So if your game is running really, really, really fast, you may have 10 updates for every fixed update call. If it's running really slow, you may have 3 fixed updates for every update call. It all depends on your frame rate and your settings. So the reason for this is that our fixed update is there to control physics stuff. It's there to keep in sync with our physics system. So it's where we're supposed to do physics stuff. But what happens is people run into an issue where they want to read input and then they want to push some physics data. So they end up doing them all in either update, they read it all in update and set the physics data, or they read it in fixed update and set the physics data. And both of those have pitfalls. So let's take a look at what those pitfalls are. I'm going to just pull up some commented code as an example. So here's our ideal situation. Say we're reading a jump in input and we're applying the force in input. Totally fine. Or if we're reading it in fixed update and we're applying it in fixed update, everything would be fine if we were in this state where we have an update and a fixed update back to back every single time. But this is not real world. That's not going to happen. It's never going to happen. Don't rely on it happening because it won't, and you're going to run into problems. Let's look at what some of those problems could be. So say we are just reading the input in fixed update because we're like, hey, we know that we have to do physics stuff in fixed update. So we're not going to do it in update. You know better than that, right? So we'll just read the stuff in fixed update. What could go wrong? Here's what could go wrong. So say we got an update and a fixed update. Yeah, whatever. We'll ignore those. Nothing happened. But then here on line 66 in this update, the player has pushed the jump button, whatever that is. It's the button on their controller or their mouse button or something. So get button down returns true. So if you call the input.get button down, pass in fire 1 for that left click or left control, then that would return true. And so would get button, because get button returns true as long as the button is down. But let's go to the next frame. We read the next update. Get button down returns false, because get button down returns true only for the frame where it's red, or that one time. So now it's no longer true. And when we go into our fixed update and we try to read our get button down there, it's false and they don't jump. And they go, what the hell, our jump isn't working right. Okay, well then we'll just move it all to update. Nothing bad then, right? Well, that'll fix it. Shouldn't be a problem. But we do the same thing. We go down here and we look at our moving in our update. Say we read the input in an update and then we move with the input. Then we read the input in another update and we move with the input. We've already moved 2 times in one physics frame, and realistically we could end up moving 5 or 10 times. We can easily miss collisions and cause a lot of other problems with our physics system. So we don't want to do either of these, but there is an easy solution, and that's to just read the data in our update and handle the data in our fixed update. So let's take a look at what that actually would look like. Well, first, let's go back over to the editor and see what this feels like one more time. So I come over here, I run around, I can go left and right, I can go up and down, and if I left click, I can jump. So that's what our controls are. That's how everything works. And before we go to the code, I just wanted to, again, thank everybody who does. Please just go hit more people watch, coworkers, better. So thanks to everybody on Patreon. I always just want to say rigid body fields here, a move and a jump multiplier. You can see that Ryder is smart enough to know that I've actually set the value to 200. 10 is not the value that I'm using. 200 is the value. I love Ryder. It's a freaking awesome feature. Okay, then we've got a rigid body here that we're caching in our awake. So our awake just gets that rigid body component. We have a vector for our movement force and a